Good morning to everyone. This is Karthick Kumar, Assistant Professor, Department of Information Technology, JJ College of Engineering and Technology. Topic is CS355 Neural Networks and Deep Learning. My flow of presentation as follows. Introduction, IoT security, deep learning basics, hyperparameters, and conclusions. So my presentation core idea is what is the IoT security and what is the impact of deep learning in IoT security. So for that my flow of presentation will be the introduction about Internet of Things and what is meant by Internet of Things security and what is meant by deep learnings and what is the impact of deep learning in IoT security and what will be the conclusion. So this is my flow of presentation. So as introduction, the Internet of Things, it's a definitions about interrelated things and mechanical devices. The digital machines provided the unique identifiers. So the information exchange between one device to another device without recovering human to human and human to computer interactions. So as we seen in our diagram, so the Internet of Things connected in various devices and the information exchange between one device to another device without human to human or human to computer interaction through internet. So that is the definitions about IoT, Internet of Things. And the main problem and the main key aspect, that means main issue is the Internet of Things, it's called IoT security. For example, in the diagram itself, the IoT devices, the applications and services in already use. But the Internet of Things security problem will be a vital role as in real-time applications because it leads to the greater number of computing line. IoT security is almost importance. So the IoT devices and services can serve as an entry point for cyber attacks and compromising sensitive data like a threatening of safety of individual users. For example, variety of IoT networks are available. IOBT, IOMT and IOHT. What is meant by IOMT is called Internet of Medical Things and IOHT stands for Internet of Health Things and IOBT stands for Internet of Battle Things. So different type of applications we are using in different fields. So when we go for a poorly secured IoT devices will lead to so much of leakage of sensitive data. For example, in COVID period, the Internet of Medical Things will be a vital role. So our doctor will be somewhere and the patient will be somewhere. So things about the important details of patients will be sent to the particular doctor. So doctor will reveal that the patient's details and based on that he will give some patient's details, treatments and all. So if that IOMT devices networks poorly secured means all the sensitive data will be leaked, spoil the patient's details. So that much impact is creating by IoT security. For example, in this diagram, the bot master will be somewhere. He is outside of the particular internet, IoT network. And he will create some command and control and he will create a bots, n number of bots, and he will create the DOS attacks, brute force attacks, phishing attacks and sperm generations attacks and malicious activities, and it will lead to target that particular IoT network. They will spoil the entire networks. They will replicate the data. So that much impact is creating by the bot master. So that IoT security will be a vital role nowadays. And as an information, what is the latest real-time security attacks? It's called the zero-day attacks. So that zero-day attacks will spoil that all the Internet of Medical Things network and it will spoil the entire networks. So we will see some solutions, how to find the solutions for these cybersecurity attacks. So that's why we are going to use the computational intelligence techniques. So the solutions for the cybersecurity attacks, it's called computational intelligence techniques. What is meant by computational intelligence techniques? That play a vital role in a cybersecurity attack, significant advantages in the speed of accuracy and adaptability. So all the computational intelligence techniques will play a vital role in the nowadays cybersecurity attacks, detection and mitigations. So there are variety of computational intelligence techniques like AI, machine learning. The subfield of AI is called machine learning, and the subfield of machine learning is called deep learning. So all the techniques nowadays, it's played a vital role when we go for mitigations of cybersecurity attacks. And now we are going to see some of the introductions about machine learning, and we are going to detail explanations about deep learning. Okay, so first of all, the definitions about machine learning, it's called the field of computer science, the computer's ability to learn without any explicitly programmed. So that is the definitions about machine learning. So first of all, we are going to gather the data from the Internet of Things, and we are going to train it by machine learning algorithms. So based on the testing, we are going to predict that output. So that is that the definition is called learn without being explicitly programmed. Okay, so that is the definitions about machine learning. And there are types of machine learnings are available. The first one is supervised machine learning, and the second one is unsupervised machine learning, and the third one is reinforcement machine learning. So first of all, the definitions about supervised learning means we are going to detect that particular output by means of labels. It's called supervised learning. So that equation is telling that y is equal to f of x. So the output of f of x, we are going to find that means of x and y labeled. Okay, I am telling one example to you. As a supervised learning, we are going to detect the cybersecurity attacks happen or not. So by means of labels in the data set, we can predict that supervised learning techniques. And the second type is unsupervised learning techniques. Some of the data sets may be not that labels. So we are going to find the unlabeled data by means of the patterns which relationship between the data sets. So without label, we are going to predict that output is called unsupervised learning. And the third one is reinforcement learning, is based on trial and error method. So for example, we are going to predict that f of x output by means of z. Z means here trial and error method. First we are going to do some experiments. Based on the feedbacks, we are going to update that networks, and we are going to predict the output. Again, it's called reinforcement learning. Okay, so these are all the various types of machine learning. Right? Okay, there are variety of algorithms also available. Random forest algorithm, decision tree algorithm, KNN algorithms. So much of machine learning algorithms are available when we go for computational intelligence techniques. And here we are having the types of classifications, regression, and clustering. So when we go for the classifications, when we go for here regression, and when we go for the clustering. For example, we are going to detect the breast cancer. So the real-time problem here is we have to predict the breast cancer by means of machine learning algorithm. Okay, then the second real-time example, the cyber attack detections by means of machine learning algorithm. So the classification here, it's called a binary, whether security attacks happen or not. So that kind of problems, we can use such a kind of supervised learning algorithms. And the second one is regression. For example, such a kind of data will be in a continuous manner. Weather forecasting, rainfall detections. So for that, we are using that data will be by the regression algorithms. So these are all the types of learning when we go for machine learning techniques. There are variety of algorithms available. So depends upon the problem statements and the efficiency algorithms we can use. And now we are going to do the core topic. So now we are going to give us solutions for the cyber security attacks. So that's why we are coming the part of deep learning. Nowadays, one research told that all the algorithms, when we go for machine learning algorithms, the deep learning algorithms are superior. It is outperformed when we compare the machine learning algorithms. So nowadays, there are variety of real-time applications will be predicted by deep learning algorithms, like health sector, cyber security attacks, and agricultural also, these kind of deep learning algorithms are available. So we should learn thoroughly about this deep learning basics. So in following slides, the next slides, we are going to study some basic concepts about deep learning. Okay, and followed by we are going to discuss on cyber security attacks and how we can give a solutions for these cyber security attacks and mitigations by means of deep learning in the upcoming slides. Okay, so the deep learning is a machine learning subfield and it's having multi-layer neural networks and for learning the data representations. So for example, the deep learning is having three layers. The first one is input layer, the second one is hidden layer, and the third one is output layer. So we are going to feed the data in the input layer and we are going to process by means of hidden layer and we are going to predict the output in the output layer. So that is the multi-layer concept. We are going to give a abstractions about the data for accurate predictions. So that's why we are going in the deep learning. Okay. And we, for example, if we are still going to study one concept means we have to know the importance of deep learning. Okay. So why DL is useful? So it provides a flexible learning framework for the representation of text, images, and visual. So nowadays, the deep learning is a hot topic in the healthcare sectors. Peculiar diseases are predicted by deep learning algorithms in an accurate manner. Okay, for example, Alzheimer's disease detections, breast cancer, skin cancers, and even all the healthcare problems will be solved by this kind of deep learning algorithms. Okay, and the effective end-to-end learning systems. And one data about 2012, the data told that the DL is outperformed other than machine learning algorithms. It will be used so much in speech, vision, and language processing, and all the image processing applications. So that's why the deep learning is played a vital role in image processing to process the healthcare data. So this is the exact structure about neural networks. Okay, so as we said, the definition says we are having abstraction of so many layers. So in the basic, I denoted three layers here. The first one is input layer, and the second one is hidden layer, and the third one is output layer. So here we have a formula like this. What is here formula? The sigma of W1x plus B1. What is here? Okay. So let's see one by one. So first of all, we are going to feed the data in the input layer. Okay. So all the features will be incorporated in the input layer. So features after incorporated in the input layer, the weights of the input layer features will be here. So that's why it's called weight W1. W1 it's called the weights of the particular features. And the X denotes it's called features. For example, when we go for some type of cyber security attack, the data set will be the PCAP and the header files and IP address and the destination IP address. So these are all the features. So n number of features will be incorporated in the input layer. And the weights of the input layer here will be incorporated. So that's why the W1 into X. And the B1 it's called bias. What is meant by bias? So we have to weighted sum of all the weights of the input layer features. It's called bias. Okay, it's a multi-layer concept. Okay, so we are having three layers. The first one is input layer, the second one is hidden layer, and the third one is output layer. So we are going to feed the data in the input layer. So all the features will be incorporated in the input layer, and the computation will be performed in hidden layer, and the output will be in the predictions of output, whether we are going to do the real-time problems like cyber attacks and healthcare disease detections. In the formula itself, it's called a sigma, it's the activation functions, and W1 will be the weights, and X will be the features, and B1 will be the bias. Okay, so sigma it's called activation functions, and what is meant by activation functions? Whether the neurons, the entire neurons will be activated or not. So that is decided by sigma, it's called activation function. There are variety of activation functions will be used in deep learning like sigmoid and all the very important sigma activation functions will be used in the particular deep learning. And then W1x plus B will be described as the hidden layer computation formulas. And so we are going to see some of the two important activation functions. The first one is sigmoid activation functions. It is used for the binary classifications problems. Whether we are going to do, again already I am telling, there's a real-time example called cybersecurity attacks. Whether the attacks happen or not. Attack happen means 1, other attacks not happen means 0. So such a kind of real-time applications we can use in the sigmoid activation functions. And so many research papers, they have used the sigmoid activation functions will be a vital role in the binary classification based problems. And the next one, the sigmoid activation functions will be suffered from the vanishing gradient problems. Because if you are giving more number of negative values also, it will lead to 0. If you are giving positive values also, it will lead to 0. So to minimize the vanishing gradient problem, we are going to use the ReLU activation functions. So the formula is called a maximum of 0 of x. So we are giving 5 as a neuron value, the maximum of 0, 5, 5. If we are giving negative values, minus 3, 0, minus 3, that will be a 0. So that's why we are using, to reduce the vanishing gradient problem, we are using this ReLU activation functions. And what is meant by backpropagation? So backpropagation means if you are designing one entire deep learning algorithms, so output will be 99.98%. It is a prediction output, but we are expecting 100%. So there will be actual and predicted output. It's called losses. So we have to update the entire network by means of increasing, to upgrading all the losses. So we have to reduce the errors. So that's why we are using this concept is called backpropagation. And what is meant by here generalizations? So these are all the terms. It's called hyperparameters. So at last we are going to design one complete deep learning models. That deep learning models should be efficient. So that's why we are concentrating such a kind of hyperparameters. So what is meant by generalization? So there are two types of generalization. The first one is underfitting, the second one is overfitting. What is meant by underfitting and what is meant by overfitting? So some models may be high in the training and testing. And some model may be training in low error but performance in high errors. So that is the difference between underfitting and overfitting. So we have to regularize this problem. So that's why we are going to concept is called regularization. Okay, so overfitting, high capacity fits the noise instead of underlying relationship. So we have to give a solutions for this overfitting. So regularizations, that will be a solution for this avoiding. Okay, so we have to drop down all the neurons, randomly drop all the neurons to reduce the losses. So that is one of the technique is called a drop down. Okay, for example, in some other papers they will describe about dropout will be 0.5. That meaning is the entire 10 neurons will be available means 0.5 means the 50% of the neurons will be deactivated. So it will reduce the losses. So that is called a dropout. Okay, it's one of the parameters when we go for to design all the deep learning models. So this is one of the cybersecurity data set called the NSLKDD data set. It will be openly available. Okay, for example, those who are doing based on the research, they are going to do cybersecurity attacks detection and mitigation. It's an openly available data set. It's called the NSLKDD data set. It's having 150,000 of network data and it's having 41 features available in that particular data set. So in that 41 data set, there will be a 4 categorical data set and binary 6 and discrete 26, continuous 10. So based on the feature extraction techniques, you can use so many algorithms and so many techniques. We can extract all the useful features and we can design the deep learning models and we can predict the cybersecurity attacks. And these are all the attacks available in that NSLKDD dataset. So DOS, probing, U2R, and R2L. So these are all the functions about the cybersecurity attacks. For example, denial of service attack. So denial of service attacks, the hackers will be somewhere and they will own the particular control of the particular device. They will get all the control about the particular device and they will disconnect that all the devices from the Internet of Things. So that is called a denial of service attack. So probing attacks means to get informations from the duplications of all the informations, and U2R means unauthorized access, and R2N it's called remote machine to gain local access. So these are all the attacks present in that particular NSLKDD data set. So now we are coming to N. Okay. So my core topic is cyber attacks detection and mitigation by means of cybersecurity attacks. Okay, so my suggestion is we can use so much of computer CNN networks, LSTM and GRU, so much of models are available. My suggestion is when we go for the superior methods, previous methods like CNN, LSTM, we can use hybrid combinations of algorithms. It will increase the performance. It will increase the accuracy. So that's why my suggestion is produce or propose new algorithms by means of hybrid combinations of algorithms. For example, CNN, LSTM hybrid combinations. CNN bidirectional LSTM. So that combination will be helpful for you to increase the output accuracy. Okay. So likewise, you have to do a problem statement and propose algorithms and participate some international conference. So that is my suggestions. So there are variety of applications also available like healthcare sectors, disease predictions. So much of algorithms, so much of problem statements are available when we go for deep learning. Okay. So my suggestion to all the students, use all the problem statements like Alzheimer's disease detections, skin cancer detections, all the problem statements are available. So if you are any suggestions, if you are want any clarification, okay, you can approach me, I will help you. So that is my impact. So thanks to all the students. Okay, so if you are having any clarifications, my mail ID is, so this is my mail ID. So those who want to any clarifications, any doubts in this regarding this, you can approach me. Thanks for this opportunity to the management and the faculty members. Thanks to all. Thanks to students. Thanks.